This review video is going to go over law of sines, law of cosines, using sine, cosine, and tangent in general with triangles, and then word problems with triangles, as well as a few questions that involve trig identities. So here we go. Alright, we're going to start off with some trig identities and simplifying trig expressions here. And on both of these problems, what we need to do is factor. So if it helps you to think of it this way, we can pretend like this is just an algebraic expression, and if we do that, we would think of secant squared like it's x squared, and tangent squared, we think of that like it's y squared. And so we can rewrite it like this, and it might be easier for us to visualize this way the idea that I want to take out what these have in common. What these have in common is y squared. You can't just say, oh, y squared minus y squared goes away, because this first y squared has an x squared attached to it through multiplication. Remember, order of operations means multiplication has to happen before subtraction. So instead of being able to just subtract these or cancel them out in some way, I have to take them out of the first term, which leaves us with x squared, and then I take the y squared out of the second term, which leaves me with a minus 1. That's really just like a placeholder, so that if now I tried to distribute, I'd get what I had to start with. If I don't put the minus 1 there, well, then I just have x squared, y squared, and that's not the same thing. So at this point, I would switch back to secant and tangent, remembering which one was y and which one was x. Tangent squared was y squared. So I have tangent squared on the outside, and on the inside, I have secant squared x minus 1. And then I would look at my identity paper, and I would say, okay, on my identities, on the Pythagorean identities, there's an identity that says tangent squared x plus 1 equals secant squared. And what I would do is I would say, well, that's not what I have here, but if I just subtract the 1 over to this other side, then I would have tangent squared x equals secant squared x minus 1, and that is what I have right here, which means I can take secant squared x minus 1 and put tangent squared x there instead. So this would be tangent squared x times tangent squared x, which together gives me tangent to the fourth x. And that's my answer. So make sure you don't see this and get thrown off by, oh, there's like a space here or whatever. I can't just be like, oh, it's secant squared. That doesn't work. We need to factor out what they have in common instead. Kind of the same thing happens on the next one. As students, we like to be like, oh, I can just like cancel some stuff out, right? And this is just like a cosine and a 2. And you know, that gets you really close to the answer, depending on whether or not you're inclined to put a plus sign here or a minus sign. It's actually really frustrating how close it does get you to the answer, because that's really, really bad math. You can't just cancel things like that whenever there's subtraction involved on the top and the bottom like this. So instead, what we want to do is think of the top part of this like it's x squared minus 4. Because if I think of it like x squared minus 4, that would factor into the difference of two squares, which means I have x plus 2 and x minus 2. Then if I change those back to cosines and look at what I have for my problem, something does cancel out. Because now I do have things that I can cancel out, because I have a cosine x minus 2 on top and a cosine x minus 2 on bottom. And so that leaves me with cosine x plus 2. So this is a situation where you may have guessed that that was the answer, especially if this is multiple choice. You might have been like, oh, they cancel, and that leaves me, you know, with just a cosine x plus 2 on top. Well, it's not correct math, and so that's a really risky way of relying on being able to do a problem like that. So you want to try to factor and see if something cancels out. Number 3 is an actual identity, which means they're giving you the answer over here on the right side, and we're just supposed to work on the left side until we get that answer. So in general, the steps we usually take for this is we say, well, anything that's not sine or cosine, at some point I'm probably going to want to change. And so the fact that this is cosecant x, I'm probably going to want to change it to 1 over sine x at some point. I don't necessarily have to do that on my first step, but at some point I'm probably going to want to think about making that change. And then when I see something like 1 minus cosine squared, that should be something that seems familiar to me. There is an identity on our identity paper, our unit circle page, that says sine squared x plus cosine squared x equals 1, which is just a fantastic identity. And we want to compare it to what we have. We have 1 minus cosine squared x. That's really close to this, especially if we move the cosine squared x over to the other side. In order to move it, we have to subtract it. So if I subtract it to the other side, I have 1 minus cosine squared x. That equals sine squared x. So I'm going to replace this with sine squared x. And so on my next line here, I'm going to write that as sine squared x over 1. Remember, we know what we're trying to get to, and somewhere around here we should be like, oh, I've got this. I totally know where this is going. You either would want to cancel right now, or if you need to write the next step as, well, this would be a sine squared x on top and a sine x on bottom. That would be a good place to go. And then say, well, just like this is, if this was x squared over x, we all know that an x cancels and leaves us with x. The same thing happens here. This is sine squared over sine, and so it cancels out a sine x and leaves us with just sine x. Now, that's what we wanted to have, and so we're done, and so we just put a smiley face, because yay, we're done with that identity. Now, this has actually stuff that we went over a long time ago on, I think, 4, 5, 6, and 7. And they should be really easy because actually we've been doing this since geometry. We're going to find the measure of each angle indicated, round to 2 decimal places. Here's our angle. They told us the opposite side is 9, the adjacent side is 12. This is a right triangle, which means we can use SOHCAHTOA. So what I want to do is get on my calculator. I want to make sure that I'm in degree mode, which I am, so you make sure that you're in degree mode. Since it's opposite and adjacent, that means we're going to use tangent. This is saying that tangent of theta is 9 over 12. When we know all of the right side, but we don't know the angle, that's where we do this second tangent button and type in our fraction as 9 divided by 12, or you can type it in as an actual fraction. But I'm going to do second tan 9 divided by 12, and it tells me that that is 36.87 degrees. And then we're just going to do basically the same thing on number 5. So the important thing is to pick out the right trig function to use. Across from my right angle is the hypotenuse, so the hypotenuse is 13.3. This 4 is on the side that's adjacent to theta, so that's adjacent. Adjacent and hypotenuse are cosine, so cosine of theta equals 4 over 13.3. I'm going to do second cosine, 4 divided by 13.3 in my calculator. Whoa, I almost did 1303, and that would not be good. I get 72 point, and that rounds up, so that's 72.50. Because I have 72.497. The 7 rounds the 9 up, which makes it round to 50.50. So, degrees. On 6 and 7, we know the angle, we're missing a side, and so we're still going to do the thing where we figure out which trig function to use, the SOHCAHTOA. If I look at this, 13.5 is the hypotenuse because it's across from my right angle. This is my adjacent side because it's next to 51. So I need to use cosine. Cosine of 51 degrees equals x over 13.5. To solve this for x, I times each side by 13.5. Which means that x equals whatever 13.5 cosine 51 is. So I get, again, if I run to two decimal places, this rounds up. This should be 8.50, I believe. On this next one, let's see, 51.3 is the angle we know. This is our opposite side and our hypotenuse. So we're going to use sine of 51.3. That equals 15 over x. Now when I solve this, this is trickier than the other one was, because what I'm doing is I'm timesing by x, which gives me x sine 51.3 degrees equals 15. So to finish solving for x, I need to divide by sine of 51.3. If you can just remember that when x is on bottom, you need to divide, that works. But you have to remember that you're dividing by sine. Sine doesn't go first. So like in my calculator, I'm going to write 15 divided by sine 51.3. Not the other way around. Division, in division, order matters. It's kind of a big deal. So this gives me 19.22. Now the next 6 problems are using the law of sines or the law of cosines, and so if you don't know what those are, you might want to like Google them or look at your notes for your class or whatever, because that's what I'm going to be using to solve these. The times that we use each of these, law of sines happens when it's angle, angle, side. That's not an A. Angle, side, angle, or side, side, angle, which side, side, angle is a special weird case that we don't write backwards because then it's a bad word. Law of cosines we use for side, 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 and side, angle, side. Now the great thing, maybe, depending on your opinion, about these laws is if you try to use the wrong law, then it just won't work. Like you won't have enough information. Since of the two of these, the one that I think most people find to be simpler is law of sines, what you could do is just assume it's law of sines. And then if you don't have enough information, then switch to law of cosines. But the other way to do it is to know which cases go with which one. So like on number 8, we know an angle, and a side. So I'm going to use law of sines. I want to find side AB, which is the top of this because it's the side that's in between A and B. Now for our law, we're going to label this as C because it's across from angle C. 28 would be side B because it's across from angle B. We have big A and then little a. And for law of sines, this is the law that says A over sine A equals B over sine B equals C over sine C. Since all we need to do is find C, we don't even need to write A over sine A because we're not going to have to find either of those at all. So I can just start with B over sine B. Make sure that you put the angle on bottom and the side length on top. Don't get those mixed up or you'll get the wrong answer. So we're finding side C, and that's on top of sine 52. So to solve this for C, I'm going to cross multiply. I'm going to do 28 times sine of 52 degrees equals C times sine of 58. So once I figure out what 28 sine 52 is, then I divide by sine 58 on my calculator. So I'm going to type that in and see what I get for C. See what I did there? See what I get for C. Okay. I get 26.02. It doesn't hurt, by the way, to come back and look at this and say, does it actually make sense for this to be 26.02? And it does. These angles are like pretty close together, which means these sides across from them would have to be, you know, pretty close together. So 26.02 is an answer that makes sense. If you want to put units, we'd put meters. Depending on your teacher, they may or may not make a big deal about that. So you probably know by now whether your teacher cares a lot about that or not. On number 9, we want to find angle C. If I look at this, you might at first think that this is side angle side, but actually we have a side, and an angle that's not in between them. So this is side angle. So I'm going to use the law of sines. I'm going to label my sides. This is A, this one's B, this one's C. So I'm going to put 15 over sine of 123 degrees equals, I don't really need B over sine B because I'm trying to find angle C, which is not a part of that fraction. So I'm just going to skip the B's and go to 10 over sine C. I'm going to cross multiply like we did on the previous problem. So I have 15 sine C equals 10 sine 123. So I'm going to find 10 sine 123 and then divide by the 15. And when I get this answer, that's going to give me sine C. And then we'll talk about what to do with that. 10 sine 123 divided by 15 gives me a decimal 0.559. Now notice I'm supposed to round this to 2 decimal places, and I just wrote down 3 decimal places because we're not done yet. Now that I know what sine C is, to find regular C, I need to do second sine of my answer, 0.559. And what you need to do to make sure that you get the best possible answer is either to type in at least 3 decimals on this, or you should have a button on your calculator that lets you do second sine and then second answer. And so on the TI calculators, you would type in second sine and then do second sine and then do second and the negative button that's down there next to enter, and it'll put in ANS on your calculator screen, which means it's going to type in your answer. And if you do that, you should get 33.99. And it rounds down because there's a 4 in the next spot. And so if you don't do that, if you just type in second sine of like 0.56 for instance, you get 34.06. Now that's really, really close. Depending on your teacher, they may be super picky or they may not be super picky. But more importantly, this is multiple choice. You would want to get the answer that the multiple choice has, and they're probably going to have this one where we didn't round until the very end and not the one where we rounded in the middle and then had to round again at the end. So just a little FYI there. Number 10. This is also side angle, so we're going to use law of sines again. So I'll try not to be quite as wordy on this one since we just did this. We know A and B for sides and angle B. We're trying to find angle A. So let's set that up. So we're going to cross multiply. And divide by 23. Sine A equals 0.708. I'm going to do second sine, second answer, and I get 45.08. So on 11, I look at this and say this is side angle side, which means it's not law of sines, it's law of cosines. If you tried to do law of sines, let me label my sides real quick and show you what happens. If I try to set up law of sines, I have a over sine A equals 6 over sine B equals 9 over sine C. The problem is that I don't have a fraction where I know both parts of. So that's why we can't use the law of sines. So now that we're hopefully convinced that we need to use law of cosines, I want to find side BC, which is the bottom here, A. So I'm going to use the formula that starts with a squared. So my formula looks like this. A squared equals b squared plus c squared minus 2bc sine angle A. So I need to fill in B, C, and angle A. And I can put this into my calculator exactly how it looks. Your calculator will open a parentheses for sine, but other than that, I don't even need any parentheses. I just need multiplication symbols. When I do this, I get 43.344. And so I'm going to, because that's a squared and I want a, I need to second square root. Second answer. Again, use the answer button so you don't have to round. I get 6.58 for a. And that would be inches, since they gave us units. On 12, this is side, side, side. So this is law of cosines. I want to find angle C. So we are going to use the alternate form for our law of cosines, the ones where we have cosine of the angle we're looking for equals, and then it's a fraction. So the one with cosine C should say a squared plus b squared minus c squared over 2ab. So we're going to fill this in and then type it into our calculator. Now I need to figure out which is A, which is B, and which is C. So 8 squared plus 15 squared minus 20 squared over 2 times 8 times 15. When I type this in, I need to make sure that either I use the fraction button on my calculator, which on the TI graphing calculators is the alpha y equals button. We'll bring up your fraction menu. Or I need to put the top in parentheses and the bottom in parentheses with the division symbol in between them. If you don't do one of those two things, the calculator thinks you're doing something that you're not really trying to do and gives you the wrong answer. That would be really sad for you. I don't want that to happen. So use parentheses or the fraction button. What we get is negative 0.4625, or you might get on your calculator a fraction, negative 37 over 80. Now, whichever one you get, we still need to do second cosine of our answer. And so if you see this and see that it's a negative and that freaks you out, well, it's okay, because once I do second cosine of whichever of these it gives me, it's going to work out to give me a positive answer. It's going to give me a positive answer that's bigger than 90. That's why it's a negative before I do the cosine of it. So this gives me 117.55 for angle C. And then 13 here is side angle side again. So we're looking for AC, which is the bottom here, which is B. So this 14.1 is side A, and 29.7 is C. We're going to fill it into the formula that says B squared. Which is A squared plus C squared minus 2 times A times C times cosine of our angle. I'm running out of room. I ran out of room. Don't worry, I can fix this. Can I fix this? I can fix this. Sorry, I had a moment of doubt. 118. Well, that's an interesting problem. Okay, so I'm going to type this into my calculator. 14.1. I forgot to write the squareds here. So the formula is A squared plus C squared minus 2 times A times C times cosine of B. So 14.1 squared plus 29.7 squared minus 2 times 14.1 times 29.7 times cosine 118. So for B squared, I get 11. No, I don't get 11. I get 1470.129. And so I'm going to square root both sides. I'm going to use the second square root second answer, and that gives me 38.34. Which would be in kilometers on this problem. Find the area of each triangle. So there's two formulas that we use for oblique triangles. And one of them I don't think has a name, and it's 1/2 times, and then it's the two sides multiplied together times sine of the angle And so in your actual formula, if you wrote it down, you probably have like an A, a B, and then a C or something like that. But it doesn't really matter. As long as they give me side angle side like on 14, then I just need to put 15 and 4.1 where I've written sides and 67 where I have my angle. So I get 1/2 times 15 times 4.1 times sine of 67, and it gives me the area of this triangle. If you want to, you can type 0.5 instead of 1/2 into your calculator. I type this in and I get 28.31. And since this is area, it's in inches squared. The other formula that we have is a little more complicated. We first have to figure out what S is. S is 1/2 of A plus B plus C whenever A, B, and C are our side lengths. And then the actual area formula is the square root of S times S minus A times S minus B times S minus C. All of that under our square root. So if I label these A, B, and C, I just need to fill it in first to the S formula and then to the area formula. So S equals 1/2 8 plus 14 plus 14, which gives me, make sure you add them and don't multiply them, the A, B, and C. This gives me 18. It should end up giving you something that's like bigger than all three of these sides, but not a ton bigger necessarily, depending on how big the sides are in the first place. What we just basically found was like half the perimeter of our triangle. So it should be bigger than our sides, each of our sides, but not super big. So this is 18, and then 18 minus A, 18 minus B, 18 minus C, all underneath a square root. You can type that in exactly the way it is into your calculator. And I get, trying to make sure I typed it in right before I tell you, I get 53.67. And that would be miles squared, because area is always in units squared. So whatever your units are, you square them, and that's your answer. The rest of the problems we're going to go over are word problems, so get excited. The best thing to do is to draw a triangle, and so we need to think about what they're telling us. So on 16 it says, an energy company uses one wellhead to drill several exploratory wells at different angles. So we're drilling wells, which implies we're drilling into the ground. They strike oil when they have drilled 2,783 feet along an angle of depression of 49 degrees. So they're not drilling straight down, they're drilling at an angle. And so up here, let's see, up here's the ground, and so they're drilling at an angle of 49 degrees, an angle of depression, which means that we are going to be looking down from the ground. And so angle of depression means you're like up high and you look down at an angle like this, 49 degrees. They drilled 2,783 feet along this. So that's this side of what's about to be a triangle. If I just finish it right here, because they want to know the depth of the oil deposit. Well, the depth of the oil deposit, if down here is where we struck oil, then the depth that we're looking for is this side. And so this 49 degrees is over here. That makes this the opposite side that we're looking for, and what we know is the hypotenuse. So we want to use sine. 49 degrees equals x over 2783. So I'm going to times both sides by 2783. And I type that into my calculator. And I get 2100.36, but it says to round to the nearest foot, so I'm actually going to round this to just 2100 feet. And that kind of makes sense. I did not draw this very much to scale. 49 degrees would actually be close to a 45-degree angle, so it definitely should have been where these two sides should have been a lot closer to being equal. If it helps you to try to draw it more accurately, because then you can think about if your answer makes sense, then you probably should try to draw it more accurately. I'll try to draw better on the next one. When an airplane leaves the runway, its angle of climb is 15 degrees and its speed is 300 feet per second. Find the plane's altitude relative to the runway in feet after 1 minute. Round your answer to the nearest foot. So we've got a runway along the ground, and then we've got the path of our airplane, which is at an angle of 15 degrees, and so that's not a very large angle, and we are being asked to find the altitude to the nearest foot. So that's going to finish off our triangle right there. What we know is that the angle of climb is 15 degrees, so that's like our angle of elevation. And we know that its speed is 300 feet per second. Now, what that means is that we can use that to find how far it's gone. That'll be our hypotenuse. If I want to know how far it's gone in 1 minute and my speed is 300 feet per second, I'm going to have to think about one of two things. Like, I either need to convert my speed from feet per second into feet per minute, or I need to convert 1 minute into seconds, whichever is easier. Probably easier to say 1 minute is really 60 seconds. Now that they're in the same units, I times by 60 seconds so that I can get feet as the distance. That gives me 18,000. So 18,000 feet is how far it's gone and then I'm trying to find the altitude, which is this blue side of my triangle. So I'm going to use sine again. Sine of 15 degrees equals x over 18,000. I'm going to times both sides by 18,000. And get my answer of 4658. Oh, we're rounding to the nearest foot again, so this is 4659. And this is in feet. And that should make sense. This time I drew a more accurate triangle. 18,000 is really big. In comparison, x should not be as big, so we got something that was, it's still a big number, but it's nowhere near as big as 18,000. 18, a communications company erects an 84-foot tall cellular telephone tower on level ground. Determine the angle of elevation to the top of the tower from a point 47 feet from the base of the tower. Round your answer to 2 decimal places. So we have the ground, but this time we've got a cell tower that is 84 feet tall. And so we're talking about being 47 feet away from that. So I guess my ground should be comparatively smaller. 47 versus 84, right? So what we're trying to figure out is that if this side is 84 and this side is 47, they want the angle of elevation. Angle of elevation is from the ground looking up. So we want this angle of our triangle. So we have the opposite and adjacent side, and we're going to use tangent theta equals 84 over 47. So I'm going to do second tangent, and then type in 84 divided by 47, and I get 60.77. It does say to round to 2 decimal places, so 60.77 degrees. Number 19, a ship leaves port at noon and has a bearing of south 31 degrees west. The ship sails at 20 miles per hour. How many miles south will the ship have traveled by 6 p.m.? So there's a few things going on here. We're leaving, that was bad. We're leaving port, and we're going on a bearing of south 31 degrees west. And so what we have to do is say, well, south is down here and west means I'm going to the left. So that is a bearing that's going to be in this general direction. South 31 degrees west. And so inside of this right here is 31 degrees. I'm actually going to make this a bigger triangle now that I know where I'm starting. What we want to do is figure out how far it's gone south and how far it's gone west. Because when the ship started, it was up here. Now the ship's down here. So how far did we go south, which will be this side? How far did we go west, which will be this side? They didn't actually tell us the length of the hypotenuse because they told us the speed of the ship. 20 miles per hour from noon to 6 p.m. That's 6 hours. So we're going to do 20 times 6 and get 120 miles for our hypotenuse. And then we're going to find x and y separately. Like if I want x, that's my opposite side from 31. So I'm going to use sine, but then whenever I want y, that's the adjacent side, so I'm going to use cosine. And both of these I'm going to times by 120. So the first one I'm going to do 120 sine 31 and get, round our answer to 2 decimals, 61.80. And this is in miles. and this is how much he went west. The ship went west, I mean. Then I'm going to do 120 cosine 31 and get 102.86. And that's how far the ship went to the south. So that's the two parts of my answer that it wanted. Now, this is quite a problem. I mean, there's a lot of words here, so bear with me. After a severe ice storm, Jimmy stood on his front porch and noticed that the tree in the front yard was leaning 5 degrees from vertical toward the house. From the porch, which is 105 feet away from the base of the tree, he noticed that the angle of elevation to the top of the tree was 22 degrees. Approximate the height of the tree. Round your answer to 2 decimal places. So, it doesn't really matter which side your porch and your house are on, but there's like a porch and house situation going on here. And then Jimmy's over on the porch and he's looking out and he's like, hey, look, there's a tree and it is leaning, which is super inconvenient, I'm sure, as we all know about trees leaning. So the tree over here is leaning 5 degrees from vertical toward the porch, or the house, toward the house, 5 degrees from vertical. So I'm not going to draw this straight up like trees are supposed to be. It's leaning 5 degrees from vertical towards the house, which is something like this. And so that means that if I drew a line like this straight up, my angle right here is 5 degrees, and we'll use that in a second when I finish my triangle. So he basically says, oh, the angle of elevation up to the tree is 22 degrees. So that's this right here. We know the tree is 105 feet away from the porch where he's at. And so I want to find the height of the tree, which is right here. The problem is I need one more piece of my triangle. I know that this is 5 degrees outside. Together these have to be 90, so this makes 85 degrees. Then I look at this and say, this is not a right triangle, which means I'm not going to be able to use SOHCAHTOA. I'm going to have to use either the law of sines or law of cosines. I can use the law of sines because I have angle, side, angle. And so that means I might want to actually label these as A, B, and C, if it would help, because then I know that this is side B, this is side A, and I'm really trying to find C the way I labeled it. You may or may not need to do that, but we are going to have to find angle B because we know 105, which is side B, and so that's the fraction we're going to want to use to help us figure out what side C is. So in order to do that, I have to do 180 minus 85 minus 22. 180 minus 85 minus 22 is 73 degrees. So now I know all of my angles of my triangle. I'm going to set up law of sines. I can set up A over sine A, although I'm not going to use it because I don't need to find side A. I really just need B and C. So I'm not going to worry about that first fraction at all. I'm going to cross multiply. So I'm going to do 105 sine 22 equals C sine 73. So I'm going to divide both sides by sine of 73 and get C equals 41.13. That's definitely the most complicated of these word problems, and for the most part it was just the setting it up part. If I'd given you just the triangle and told you what side to find, it'd be like no big deal. So you gotta be careful and pay attention and really use your imagination in some ways to kind of come up with what's going on there. Pay attention to detail, But at the end of the day, you just got to try something and then hope it works out. So that is our review of law of sines, law of cosines, and trigonometric word problems.